If you take Newtonian gravity and equivalence principle very seriously, according to equivalence principle, something that's falling locally will say that it is inertial. Therefore, it would say that it has a straight world line, something like alpha plus beta t, right, this straight line. You look at it and you claim that it has a world line t. What that tells us is there's some kind of transformation between the two frames, which turns t into t. In other words, time is kind of stretched. If you look at it in terms of work, time is stretched. It's a function of where you are. If you have this, let's say, spherical source, and you're here or you're here, the time rate here compared to here will show up. There'll be a variation in the time amount of time passage between here and here. Therefore, you get the redshift and so on and so forth. Here, you have, at each point in space, you have a different, let's say, we'll draw the time axis. You have to stretch this one based on where it is according to r. The closer it is to the source, the more the stretch. The closer it is, the further from the source, the less the stretching. What's going to happen as a result of the stretching is a straight line turns into a curved line, or a curved line can turn into a straight line. If you stretch this, then the scale changes, and what would be curved in one thing comes straight in the other. If you just say, well, t is stretched, it becomes a function of t. Obviously, the way that I measure time in a gravitational is different than the way that I should measure time in empty space. In falling, let's say, to spherical symmetry, you know Newtonian gravity, and you found that for infalling, obviously r double dot is equal to gm over r squared. This is simply a differential equation. What's the solution? Does anybody know offhand? What's the solution for r of t? What is the solution for r double dot over r squared? It's simply proportional to t to the 2/3. Okay? All right. Does anybody know if you solve the equation r double dot equals gm over r squared, and you want to find the world line equation in flat space-time, r of t. What is r of t? What's the equation for r of t? Just in ordinary gravity, gm over r squared. What is it? Okay, what's the formula? Has anybody ever seen it? Okay, you have it worked out over there. It's t to the 2/3. R is t to the 2/3. That's simple calculus. If you take the second derivative of t to the 2/3, you end up with 1 over r squared. Okay? All right, so you have this page. You can just see it's just ordinary calculus just to find the solution of r double dot equals 1 over r squared. Simple differential equation. All right, if you substitute t to the power n, which I give as an example, you find that n is equal to 2/3. All right? You've probably all solved in general relativity, and this is also for black hole collapse. It's also for cosmology. Same thing. And this is a very important equation. In general relativity, for example, collapse to a black hole is governed by that. The Big Bang expansion, if you want to find the age of the Big Bang, this is what turns up. So this t to the 2/3 comes up all over the place. If you take Newtonian gravity and equivalence principle very seriously, something that's falling locally will say that it is inertial. Therefore, it would say that it has a straight world line, something like alpha plus beta t. You look at it and you claim that it has a world line t to 2/3. What that tells us is there's some kind of transformation between the two frames, which turns t into t to the 2/3.